Okay, oops, sorry. Okay, let's continue our class. I have to share the screen again. Share entire screen. Okay. Okay. Now we continue using orange to get the feeling about the machine learning stuff. So I ran, so this is my computer running orange. Okay. I have to activate the virtual environment. It's not CD. It's virtual environment. Orange environment. Sorry. Python is equal to Python 3 orange environment. Okay. And then I need to source orange environment being activated. Okay. So the environment is activated, so I need to run orange canvas. So orange will be running. So to be honest, I forgot about the latest. So my talk about orange last week. Let me know if I redo these things. Okay. Okay. So we need to wait a little while. Okay, now I can see orange. Now I go to example. I think we have been something like here. I'm not sure what PCA. So classification tree. Let me see. If okay, well, I think we have done classification tree. We can explore more about classification tree. For example, let me see. So we have several data set here. I close everything. So in data, we have data sets here. So we have a lot of data sets. We can play around with these data sets. This data set is built in Orange. We can select any of this data set to play around with it. Basically, so I will try to see the classification tree. Okay. We have Titanic, we have car evaluation, we have breast cancer, we have smoking effect, we have, oops, what is this? Well, I think I'm in trouble. Oops, segmentation fault. I have to rerun again. Restore unsafe. Change. Seems to crash. No. Okay. Because we are just starting. So I close everything. So in data set, basically we have several data set here. We can play around with these things. So we have sentiment analysis. We have, I don't know, many things here. Okay. Most of this, to be honest, Orange is developed by biomedical researchers to make their work easier. So there are many medical data here, okay, like breast cancer and so on, okay, dermatology. To be honest, I download a lot of books on dermatology. I don't know what it is, but this seems to be very important for skin. Okay, so this is for skin. I don't know. So okay, as well as there is cybersecurity breach. So you can play around with these things. In we can start with Titanic. That's the easiest one, Titanic. I can select Titanic here, and then that's it. So we can check the data, drag the data table and connect the data set to, connect these two, and we can see the data of Titanic here. Basically, it showed the summary. We have 2,201 instance, no missing data. This is important. We have 3 features, 1, 2, 3, status, age, and sex, and we have 1 target value. This is yes or no, dead. Yes means survive, no is dead, basically. So, but it already remove all the privacy data, the real name, the real age is removed. So we can analyze using more generic data. So basically the status is first class, second class, third class, and crew. The age is adult and kid, and the sex is male and female. That's it. Okay. So normally I will normally ask you to think, so the data is only like this. Okay. This is the actual data. Okay. The important thing in this data, if you see the data is text. These are not numbers. This is text. Okay. First, second, third, adult, kids, male, female. Text. This is text data, and the target data also text. Yes or no, but text, not 1 or 2. So there is no numbers in the data, only text, and we will analyze text. Okay. If we remember, I think last week I show you the model, basically a linear model. Ax plus b is equal to y. So these are x. Status, age, and sex is x in the linear equation. This is the x and this is the y. So we'll predict y. Okay. Basically, we need to classify y. Okay. Now, based on this data, normally this is like decision support system. This one is see how we see the decision tree based on this data. So I normally ask people, okay, if you are the death angel, you want to take somebody we want to make somebody dead, and then you need to decide based on what parameter. We basically only have 3 parameters here: status, age, and sex. So we need to decide based on this parameter if a ship, this is Titanic, if a ship like Titanic sink, and then the death angel need to decide which of the passenger have to die based on this parameter. Okay, so we have this data, and then we need to see how the decision made. Okay, which parameter the death angel we see first, whether status, age, or sex. So basically, in this situation, we need to select which algorithm is best to do the analysis. Okay, to see which algorithm is best to do the analysis, we normally check evaluate. We have test and score. Okay, you can also do in Python. There is if we check here, oops, there is no. We need to select the okay, we need to fit the data to the test and score, and then we need to select which model we want to evaluate. For example, we have 3 algorithm: random forest, gradient boosting. We have, because this is classification problem, we can use logistic regression, we can use naive Bayes, and so on. So we have several algorithm here, and we can check which one is the best one to deal with this kind of model. So this is how to program these things. Okay, you can always use Python to do these things, but to get the feeling, it's better to use this orange. Okay, so orange basically will show you the insight, or you can get the feeling how it works without having to deal with the actual syntax or of coding. Okay, so if we after we fit the model to the test score, and then we can see this. This is the results. So we have several output. This is precision, recall, F1, and so on. So basically, we can always change the parameter. This one is we have 10 volts, 10 number of volt. We can also use random sampling if you like. Of course, it will generate different results. Okay, so it's still working. Okay, now we have different result. If we use random sampling, we can change how many train tests done. We can reduce to 5, we can increase to 10. So we can play around with these things. Okay. For the training set, how many percentage from the actual data? This is like 66%. Okay. We can increase to 75% or so on. Of course, it will recalculate again everything. Okay, so we get these things. So basically, we have tree and random forest is the most precise, like 81.8% both. And gradient boosting is a little bit low. Logistic regression the lowest, and if bias is a little bit higher at 77%. So this is the important one when we play around with these things. But make sure we are not overfit the model. So sometimes the training size is we play around with training size to make sure it doesn't overfit. Okay. So this is how to play with these things. For simplest one, you can do cross validation like this, and that's it. Basically, it will show the similar results. Basically, tree and random forest is the highest. See this? Oh, okay, tree is the highest. Random forest gradient boosting slower. So basically, tree is consistently highest. So in this case, I will use tree, okay, as the highest one. Okay, now remove this one, so I will use 3. Remove all of this. Okay, remove this one. Okay, so we have 3. Oops. Okay. Okay. So if data set entry, so I fit the data to the model, 3 model. Now the next step is we want to visualize the model. Okay. See this one. So this is model. We visualize. We have 3 viewer, box plot, many things here. Okay. I think I wrote, I think I have a video on which one is which. Okay. But basically, what I normally do is I will look at 3 viewer, the graphics. The graph I normally use is 3 viewer, scatter plot, line plot. That's it. The rest I hardly use, to be honest. I normally use only these 3. 3 viewer, scatter plot, and line plot. That's it. Sometimes distribution as well. Okay, so basically I only use 4. The rest, yeah, okay, we have a lot of graphics we can use. Okay, for 3 viewer, 3 viewer is quite fit with 3 model because we can see the results, the 3 results in 3 viewer. So basically, that's it. So this is machine learning. So we have input data, model, and output. View the output. That's it. So this is basically, if we look at machine learning process, basically we goes to this kind of structure. Read the data, algorithm, and view. Okay, I will show you the view. Okay, this is the results. Basically, I reduce the depth into 2 level. So basically from here we can see exactly the most important one for this is target class is yes. Yes means survive. How about no? Dead. So who will be for the angel of death when he decide who will live and who will dead? So we can see the main important parameter is actually the sex. So if you are male, you will likely to be dead. Okay, so 78.8 sorry 67.7% of male is dead. Okay, so only female live, and then after that we can see 26.8 is selected by status. Okay, let me see. So this is how the decision process is made. First we see the sex, and then for female we see the status. The third class will likely 80% will dead. The crew first class and second class only 73% is dead. Okay, so from the status you can see only 26.8% female death, while male 78.8% death. Okay, from the age, if you are an adult, you will likely to be deaf, and around 50% of the child is dead. So we can see how the decision process is made. Okay. Remember that the data is text only. There is no numbers, no but only text, so we can predict, we can see how the decision is made based on text data like this. Okay, of course we can do mix text and numbers, but in this case we have only text. Okay, so that's the beauty of Python, machine learning, Orange, and so on. We can actually deal with mixed data. We can have number, text, audio, video, and everything on these things. On this, in this thing is we have text. Okay, close this one. Okay, let me change the data a little bit. So I check. So we have several data sets. The other interesting things is car evaluation. This is in car dealer. Okay, we have 1,728 instances with 7 variables, which is the X things, and then 1 target, categorical target. Okay, the most difficult one in machine learning is basically we have to know which one is the variables or the X in linear equation and which one is the target one. So we need to decide. Sometimes the variable can be set as a target, or target can be set as variable. We can switching between target and variables. Okay. And then sometimes we need to decide, for example, we have a lot of variables. For example, like this one, breast cancer. We have 9,486 variables here. So we need to decide which one is the important ones. Okay, so that's, in this case, we have the target has been decided yet. The target has been decided. So this is like supervised learning, which is the target has been decided. If the target is not decided, that's more challenging. That's unsupervised learning. Okay. So this one, chronic lymphocytic leukemia peripheral, we have much more brutal variable. We have like 16,000 variables here. So this is more difficult to play around with it, but we can play with these things. Okay, now I will select the car evaluation here. Okay, download the data is something like this. So let me show you. So we have 1, 2, 3, 4, 5, 6 feature or variables. Okay, we have a lot of instances, 1728, and so we have 6 features. We have 1 target with 4 values. Okay, unacknowledged or unACC means people don't buy. There is 4, I think, and ICC, and then what else? ACC, and then what else? Good, very good. That's it. So we have 4 here. And so this one, the variable is mixed between text and numbers. So we have buying is high. This is the buying means the price. The price is high, very high, something like that. Maintenance is very high, high, low, medium, something like that. The number of doors, 2, 4, 2, 3, 4. Person, 2, 4 more. So this one is more interesting. We have 2%, 4, and more. So we have mix, number, and text. So Orange Python can do analyze something like this. So it doesn't care about the whether it's text or numbers or something. So we can do something like this. Okay. So this is the luggage booth. We have small, medium, big luggage, safety, low, medium, high. Okay. So the problem is, so this is the data from car dealer. Okay. So we have the data if the price is high, maintenance is very high, door is 2, person is 2, the luggage booth is small, safety low is unACC, is people don't see it. Okay. For example, if we have, let me see, this is very good. So buying low, maintenance high, door 4, person more than 4, luggage put big, and safety high. People will buy. Very good. Very good options. So that's the only data. Our problem is how to see how people decide. So we have 6 variables here: buying, maintenance, door, person, luggage put, and safety. Which of these parameters is the important ones? Okay, when we have this data, this is the mindset of the data scientist. Okay, we have 6 features. Which one is the important one that will decide the final result, whether the car will be where people will be buy or not or whatever. So we have to decide between these 6. Okay, now the we use 3 model as well. Now we can see the 3 viewer. That's it. So the important one is actually person. How many person in the car? Okay. So let me see. The target class is an ACC, for example. So actually an ACC is people don't see it. So 70 or very good. Change it into very good. Okay. So out of 1078, only 64 people actually decide that this particular is very good. So okay, and then so the first thing is the number of people in the car. Okay, that's the important one. How many person in the car? So, but this is actually only 3.8%. Okay, but that's the important ones. Okay, so that's person, and then after that safety. Safety is the second feature they want to see. The first feature is person. The second feature is safety. After that, they will see the price. So price is actually the third variable they want to see. If it is in Indonesia, normally Indonesian people we see the price first. Actually, the reality is not that. So we see the number of person, safety, and price. Indonesia may be different. Price is number one. Safety is the last one. So price, person, safety. So that's Indonesian. Let me increase the level. So first, person, safety, price, and then maintenance fee. But this mix feelings between high, very high, and low, medium maintenance fee. So this one is mixed. Okay, and then that's it. The fifth level is luggage. Okay, so basically the four important one they want to see is person, safety, price, and maintenance. That's it. Okay, of course you can play around with the target class, which one we want to see, whether good, same, basically, ACC, same, unacknowledged, same. So basically we see these things here. Okay, okay, let me see if you have any questions. No questions? Okay, continue. Okay, so this is tree viewer. Okay, so that's tree. Okay, now we continue with different example. Oops, oops. I think I closed these things. I have to rerun the thing again. Okay, so that's three. That's interesting one. So now I see the other example. See, so we have three classification. Now we can see the principal component analysis. So this is what? This one is a little bit cheating. Especially important if we have to see like lot of feature. We want to analyze a lot of features. Open. Let me see which file we use here. So we use brown selected. I think this is like biomedical stuff. This is alpha 0, alpha 7. I don't know. This is like protein and stuff like that. I don't know what it is. But basically we have 79 feature with 1.8% missing value. We have a category class with 3 value, no missing value. Okay, and one meta attribute, which is like information only. We don't need to process the meta attribute. So basically we have protein and the classification, one classification. Okay, now we need to create the model. On this particular workflow, it uses PCA. PCA is principle. I forgot what it's called. It's sorry. Wrong. Help example workflow. PCA is principal component analysis. Okay. Now, basically, let me okay. To visualize these things, to visualize PCA, basically it maps the it maps the like we have 79 feature component. We want to map the 79 component into smaller component, like this one only 2. Of course we can change into like 3 components, or we can make it 5 components and so on. This will show the what's the percentage it can explain if we map from 79 into 5. If we map from 79 into 2 component only, we can only cover 35% of the variance. Okay, so basically like this. To visualize these things, basically you need to understand the 3D mapping to 2D, for example. Of course, you understand 3D, right? Three dimension, not image, axis like that, 3D axis. So we have 3D axis like this, X, Y, Z. That's the 3D axis. So we have a box here. So we have 3D axis, and we can play around with this in 3D axis. In our case, the axis are not 3. In our case, the axis is 79 axis. So that's more brutal than 3 axis like this. So in traditional way, we have 3 axis like this, and we can to design to visualize in our screen. Normally we need to map the 3 axis, map to 2 axis. No, not these things. Okay, 3D to 2D. Let me see. Okay, so this is the mapping. So we have 3D here and we have 2D here. So this is from this angle, this one from this angle, and this one is from this angle. Okay, so we have 3D and 2D. Okay, so this one is 3D, this one is 2D. Okay, so you can see the difference here. So these two are 3D still. Okay, this one is 3D, this one 2D. So we have 3 different view for 2D. Okay. Okay, this is 2D, this is 3D. So basically, so that's the difference between 3D and 2D. So that's what happened with PCA. PCA, where is it? Okay, PCA. Basically mapping the 79 component into how many component we like. We can make it into 2 component, but it's brutal. We can only see 35%, or we can map into like larger percentage. We can see 18, map it into 18 components, so we can cover 84% of the data. So that's basically PCA. Okay. So using PCA, we can do plot, we can check the data. Okay. So let me see, the actual data is like this. So this is the actual data. This is the meta attribute protease. I think that's the name of the protein. This is the target. Okay, and this is the feature, which is 70 something feature. Okay, but we don't need to analyze. We want to use PCA, so only mapping from 79 feature into less number of features. So if we do, for example, we can map into like smaller number, like how many? 3. Okay. We want to see the data now. So this is the actual data now. Okay, see this? Only 3. The name of the column is different. This is PC1, PC2, PC because we use PCA. So we rename the column number, column name, and then the target still the same, but the column name is changed, and the value is basically the mapping value from the 79 feature. Why we need to do these things? Because we need to conserve the CPU time basically. So we of course the computing power is much less if we analyze only 3 column rather than 79 column. So this is why we do these things. Okay, so that's PCA. Okay. Okay. Now the other thing we can do rather than PCA, we can do something like this. Let me remove this thing. I will remove this. Okay. So the file is still the same, the brown selected, which has 79 features and one category classifications. Okay. Sometimes what I normally do, I do rank like this. Okay. I want to see which column is the important ones to the target. Okay, the rank is different. The way of thinking of rank is different. Basically, it will try to identify which column is the important one to the target column. Okay, so this one we have several algorithms here. We have information gain ratio, Gini decrease, ANOVA, chi-square, relief, FCBF, and whatever. So we have several algorithms to analyze. So based on different algorithm, I think you need to check on ChatGPT which one is the best one for your case. But basically, these are the algorithm available on Orange. Okay, we can change. This one is 6 best rank. Of course, we can change it to 7, 8, or only 6. Okay, so this is the 6 best rank. Depending on the algorithm, for info Gini, we have to click the column. Okay, so these are the important rank based on information gain. Okay, and this is DAO-F, SPO early, DAO-G, SPO5, hit, and these are the important one. The rank may be different from different algorithm. This one, the gain ratio, still same. This one, the Gini, still the same. So a little bit different. So we have little bit different here. Okay, let me see. Okay, different. This one different. Okay, ANOVA, little bit different. This one, but there are some. If we want to cover more, make sure we cover all many. We can increase the number of column to like 12. Hopefully, although it may be different, we cover many of the important ones. Okay, so it's maybe different, something like that. So this one is okay. This is chi-square. Okay, so you can select something like that. This one is much different. This one is much different. FCBF. So we can select based on this criteria. After that, then we can, based on the selection, then we can move forward to the process, and only this column will be selected. Where we can select the column is using this figure, select column. Okay, let me see if it goes automatically. Let me see. Okay, it's not automatic. Let me see if I can. Oh, okay. Oh, yes. Okay, let me see. Okay, I change into like 5 or 6. 5, only 5. Let me see. So I will select these things. Only 5. Let me see. Okay, right. Okay, that's automatic. So we can select how many column you like, and using select column, we can see only the selected by the algorithm. Only the selected column will be processed. Then after this, we can let me finish so basically We have the data. We analyze which column is the important ones, and we select the column. So basically on these things, I select only 5 important ones. Okay. Of course, different algorithm will give you different column. If we want to be safe, we can increase the number of column we want to select. Okay, in this case, I only select 5. Okay. Now, based on this 5, then we can analyze what kind of algorithm is the important one. If we see the data, let me see the data first. Okay. See the data. This is actually the what's that? The target. Okay, this is the target. Gene is the target. The target is text, but it's not what's that? It's not floating point. So this is not linear regression. It's sort of classification, but lot of category. Or we can see it as linear as well. I don't know. Let me see if we can treat this thing as linear uh, data. Now, to check which algorithm is the best one, we check evaluate test score. Okay. We feed the selected data to test score. Then we need to see which model is best to deal with kind of. So we have linear regression, we have logistic regression. So we check only these two first. So I use two algorithm, linear or logic. Logic basically for classification. Normally two type. Let me use random forest, because random forest can deal with linear as well as classification. Okay. Let me see which one is best one. So it's okay. See, linear regression doesn't work. It show the cross here, and logistic regression seems to be okay. Okay, let me see the results. See, linear regression fail, but random forest give you like 97% of precision, logistic regression 98% of precision. So this is basically classification process. This is not a linear regression. And we have this number. Okay, let me see if I use different algorithm, naive Bayes, and we can always use neural network if you like. But this one is more brutal, normally, neural network. Okay, remove linear regression. See, that takes a lot of time. So, neural network is actually the troublemaker. So but many people actually like neural network because it can deal complex data. Okay, let me see which one is the best one. Neural network give you the one of the best, close to logistic regression, 98.4, while random forest only 97, naive Bayes 95. Okay, of course we can increase the accuracy of CD. This one is better. Neural network give consistently better results in many measurement here. The precision is 94, recall is 94, F1 is 94, everything is better. So this one is also okay. Logistic regression, still okay. So it's competing between logistic regression and neural network. But logistic regression is normally much faster than neural network. So if that's the case, I normally choose logistic regression because it's much faster than neural network. In neural network, we can change different parameter here. We can see the how many hidden layers, how many neuron, what kind of solver we want to use, and so on. We can change this thing here. Okay, of course we can implement this in Python, but this will give you some idea what kind of result we will get in our attempt. Okay, So I normally use this first and then implement in Python for larger data. Okay, but increase the number of neuron, or increase the number of layer and number of neuron, I increase and see what happened. Okay, I will not do that. So basically, this is how we analyze these things. You are welcome to use PCA. I personally will likely to use rank like this. So basically removing the unnecessary column, only analyze the important ones. So you can use both if you like. Okay, that's it. So that's the PCA. Okay, remove everything. Okay, now I'm. Let me see if there's any questions. Is there any questions? I have question about Wira Pratama. I have a question from your explanation. Basically, our basic frameworks doing machine learning is to have a data set. Yes, goal. What we want to see in the data set. Yes or no. Depend. Yeah, sort of. You need to have some sort of goal or target. Test score to see which method is more relevant. And I say yes. Visualize. That's it. Is there anything missing from the framework? Yes, there is something missing. Don't worry. From you can only okay. I will show you more complex framework. That's oops, sorry. I need to see the okay. The other thing, a lot of things. That's the simplest thing. Okay, let me show you more. Not complex, basically. I want to show you more challenging, not really challenging. Is it? Oops, oops. Oh, okay. This is in my server. I will shut down my server first. Okay. Okay. Server shut down. So this is my PC. Orange. Okay. Let me see. I need to have something simple. Dummy data. Linear for okay. This one is the simplest one. Let me increase the zoom in. See here we have linear forecasting, linear training data, linear prediksi, linear training data. So we have this thing, linear thing. Okay, let me see how it's look like. Okay, where is orange? Orange. This is linear. Okay. So this is the simplest one. This is very simple example. So for example, we have data like this. This is the target is Y. Okay, we have Y target. We have several feature. We have X, X1, X2. Okay, if we want, I create this file. For example, we want to analyze only two column, X and Y. So we have X and we have Y. Of course, we can do a simple analysis like this. If we want to have more column, we have X1 and X2. Okay. So we have this data, and this is the simplest one, training data, and we have prediction data. So we have X and Y like this, okay, for prediction purposes. So we have X and Y, and some of these things, there is no numbers here. Okay, so we want to predict if we have, wow. We have earthquake beside me, so don't worry. We have X, for example, X50, we want to predict how much is Y. So we can do prediction. If we do prediction, the workflow is more complex. Okay, we start with modeling first. Okay, let me see what it is. This one. Oh, this is the simple one. This one is much simpler training data. The first thing you need to do is you need to set up the training data that you can predict the results. Okay, for example, this one. I changed the training data into 9. So we can predict the result. If it is 1, the y is 7. If it is 2, the y is 8. Is 3, y is 9. 4 is 10. So this is predictable. We can always predict if x is 5, the y is 11. So that's predictable. Okay, so we can predict these things. Okay, I save this one. So the name of the file is linear training data, and then this one. Oh, but the difference is this one linear, this is linear. This one is English, this one Indonesian. Okay, this one Indonesian. This is for prediction. We want to predict if extend, how much is it? So we use this one, the linear first. Okay, I need to upload this data to this machine. So I need to upload the okay, orange 3, orange green. So I copy all the 4 files, the linear and linear. Okay, they are English and Indonesian. So I will use this one first, which is the simplest one. Okay, let me see, data file. Okay, select orange linear. This one. Oops, sorry. Okay, this one, training data. We have only 2 columns, X and Y. Okay, and then this is the actual data here. So this is the actual data. If it is X1, Y is 7, 2, 8, 3, 9, 4, 10, 5, 11. Okay, that's the actual data. Now, of course, we can evaluate which algorithm is the best to generate the model for this one. Just fit this one. Of course, we will know the actual outcome. Okay, the actual the best model will be linear regression for this type of data. Oh, sorry, I forgot. Okay, we need to select which one is which first. I forgot. Okay, we need to select because we only have this data here, X and Y. Doesn't say anything whether this is feature or target. It thought the orange thing that both are features. There is no target. So we need to tell orange which one is feature, which one is target. So we fit into select column. Oh, by the way, all of these things can be written in Python as well. So Python has also this kind of facility actually. Okay, but this is orange is much simpler, so we can play around without worry about the syntax and so on. Okay, we need to select the column. So both orange thought both are feature. So we want Y as the target. So we grab Y into, oops, doesn't work. Nope. Oh yeah, okay. So Y is target now. Okay, now after knowing Y is target, we need to test the algorithm by, so we need linear, we will check different algorithm here, tree, random forest, and so on. Okay, so we have four algorithm, 3 linear regression, logistic regression, and random forest, and then we want to test. Okay. Oops, sorry. Fit the data here. Data fit to these things. Okay. Okay. Number of holes exceed the data size. Okay, I need to change the number of holes. Only 2 folds. Okay. So if I use 2 folds, uh, no. So this one is this is the error. It's unlike the classification. We see precision in classification, F1, recall, and so on. In forecasting, in forecasting type of machine learning, the error is MSE is mean square error. RMSE like root mean square error. This one MASE is mean absolute error, and so on. Okay, so these are the errors. So the best one is linear regression. It gives you zero error, and R square is 1. So this is the best one. Of course, it is best because the data is very simple and very straightforward. The data is like this. There is no error in the data, no deviation in the data, so we will get the best result using linear regression. So we will remove linear regression and 3 here. Okay, remove test score. Oops, sorry, we remove test score here. Remove. So we use linear regression. So the output of the linear regression, oops, sorry. Okay. So basically this part is dealing with the data. Okay. So we select column of the data. This basically pre-processing. So this is the actual data. File is actual data. The select column is pre-processing of the data. Okay. And we feed the data into the algorithm, and we can play around with the algorithm. Of course, we can visualize if you like. Let me see visualize. We can do scatter plot. Okay. Let me see. This is the coefficient of the data of the model. There is, oh, sorry. Okay. I cannot use scatter plot on this one. You only use scatter plot directly from the data. So you can do scatter plot here. Okay, see this is a scatter plot. This is X and Y. You can see the data here. Okay, but not the more because the output of the linear regression is the actual data. Yeah, the actual model. Okay, so I cannot plot the model, but basically we have the model. So having the model, then we can do prediction. To do the prediction, we need different. So I introduce different one. This one, the prediction here. So this is the prediction. We fit the model to the prediction widget, and then we need to load different data. So on this one, we use linear training data. Okay, on this one, I need to use the where is linear? Linear training data, linear prediction. Okay, so we use linear prediction. We need to do select column, same select column here. Must be the same within the model and the prediction. So in this type, I want to show you the data table. See this, the Y part. there is a question mark here. For X is 50, 60, 1000. We have question mark. And this one is, I think it's correct. 10 is 16, 20 is 26. So this one is correct one. Okay. Let me see what happened if we fit the data to prediction. So the prediction, we need the model, and we need the data that we want to predict. So here, this is the actual results here. So this is the data, X and Y. This is Y and X. And then this is the result from a linear regression. Okay. So Y is 35. It must be 36. So there is one error. This one, the predicted results. There is no data here, so basically we can predict. If X is 50, the Y must be 56. X is 60, Y is 66. If X is 1000, the Y is 1006. This one is the pure prediction. There is no comparison to the actual, to the data, but we can predict like this. Okay. So this is the prediction. Now the workflow becoming like this. I will remove this one. Remove this one. So it's different workflow. So it's different now. Okay. This is the previous workflow, basically the top one. Now I'm using prediction to predict. The same thing with Python. If we use Python, we need to create a training data. From training data, we have model, and then if we want to predict, we need to fit another different data. These two data is different. This is the training data. This is like the test data or something, and then we can predict based on the model what would be the prediction. So this is one example. Of course, we can play around with many variables. For example, let me show you my paper, journal paper. You can check, but the journal is dead now. I'm not sure if I can download again. Oh, no. So Telkomnika, so I publish in Telkomnika journal, but the journal is blocked by Scopus now because they are too expensive or something. I don't know. They are becoming what you call it, predator journal. In the past, I pay only like 2 million, but they increasing the fee, and then it's blocked by Scopus. Let me see. So not this one, not this one. Nope. Okay. It's in my, I'm having difficulty to find s.id free OWP Purbo. Okay. This is in my Google Drive. You can access my Google Drive using this URL s.id/free OWP ebooks. I will put it in the chat box. Let me see. Where is the chat box? Okay. You can note down the chat box. Okay, this is the URL. Let me see, where is the journal? A lot of books here. If you like, you can download many of these books free. Where is it? Transformation Digital. Cannot find it. uh, let me see. Where is it? There is one. Okay, this must be one. Where is it? Okay. There is one, but I cannot find it. Where is it? Let me see. Oh, there are several awards. Okay, there is one with awards in it. Let's see. How come I cannot find it? Oh, no, this one. Okay, this is the one. Comparing machine learning. Okay, so this is the one. You can download these things with comparing machine learning. Okay, I will download. Scan for viruses. Yeah, there is no virus. Okay, so this is the actual, this paper published in, oh, this is not Telkomnika. I published in GTK. Okay, basically it's comparing machine learning and human judge in Satu Indonesia awarding process. Okay, now if you want to see the so this, you may familiar with these things. So this is the example of the what's that workflow. This is for testing the best algorithm for different so in this particular, this is quite complex actually. In this particular case, this is Satu Indonesia awarding process. This is Satu Indonesia award. So I have to show you what is Satu Indonesia award. Satu Indonesia awards. We are in the awarding process right now. So this is Satu Indonesia awards. So Satu Indonesia awards. It's award for young Indonesian below 35 years old. That is very inspiration in education, in environment, in health, and so on. Okay, so these are the jury. Wow, I'm number 2 now. Interesting. I normally number something. So these are the jury. We have Pak Emil, Professor Emil Salim, we have Bu Nila Muluk, we have Pak Fasli, we have Billy Boon, and so on. We have, of course, we have Dian Sastro, we have Ralin Shah here. Okay, so the awarding process is actually people can submit the nomination and then the jury will give the mark to the nomination. The nomination is based on text. So it's text, a lot of text. And then we need to analyze these things. The marking process, let me show you. Can I increase the, okay. Okay, the marking process, so it will evaluate motive, obstacle, outcome, outreach, and sustainable. Basically, it will evaluate 5 parameters. So we have text and we have 5 parameters to evaluate. And this parameter is evaluated by this jury. Okay, so then I test for each parameter which one is which model is best. Okay, and save the results. Basically, the best one is random forest in this particular case. Okay, so the feature all text features, and then we need to evaluate the text. Okay, so after that, we save the data into corpus file, pre-process the text, basically removing all the connecting word like and, to, the, all the that kind of, we processing the text, and we change the text into back of words. Back of words is basically make the text into vector. So this actually creating a vector, and then do random forest modeling and save the model. Because we analyze a lot of file, so I need to save the model first, and then having the model. So basically, we have several model for motive, model for obstacle, model for outcome, model for outreach, model for sustainable. These are different models, and then we so this model, so we get this model from older submission. So because the older submission already have mark from jury, so Professor Emil, Professor Nila, Professor Fasli, all of them already marked the submission. So based on their mark, I generate the model. So so the model is basically generated from the old mark. For the new mark, this one is new mark. So I do the prediction and save the results here. So, and then I compare. This is comparing. This is comparing between the machine model and the judge assessment. So basically, I compare these two, and the result is basically similar between machine and judge. So you can see the workflow can be very complicated like this. This is quite complicated actually. This is the more complex workflow I have been working on. Normally for class, I only give like simple workflow. Okay, so hope that's answer your questions. Okay, on workflow thing. Okay, okay, that's workflow. So you can let me see if I can. Oh, by the way, if you are less than 35 years old, or you can tell your niece or your friend, if they are less than 35 years old, they can submit for nomination in Satu Indonesia Award. The price is 65 million rupiah. It's quite a lot actually for the price. 60 million rupiah. This is 2024 winners. Let me see if what. Oh, this year is 2025, right? Okay, so this is 2024 winners. There is no 2025 yet. So this is last year winner. Okay. So this is the Irfan is building. He's built VMware competitor basically, and his product is used in several countries now, including several data center in Indonesia. So this is only the example. Okay, let me show you some of the technology winners. This one is technology winner as well. Reza Permadi is lecturer in BINUS University. He built the application for what, tourist village. Okay, so they don't have to worry about the back end for application. So he built one and he gave away the application to there are hundreds of tourist village in village tourism in Indonesia using his back end. Okay, that's the example. Let me see the important ones. The one related to AI. Okay, not this one. Let me see what this one. I'm sorry. This one robotics. 20. How about 20? Oops, sorry. This one AI. This is not Flux. Just give you the example. What kind of thing they are doing. Node Flux is basically, let me see. Node Flux is basically image vision AI company. Basically, detect vision and classify the based on vision. Can I see any? Well, you need to see the video or something. Basically, it check the CCTV in the police department or the government department, and then it can identify your face, your car, as well as in the government case, it will identify the behavior of warung. What is warung? Tenda biru. Lapak. Okay, let me see. See this, the images. So we have this kind of tenda biru in roads, and using the vision, we can see the behavior of this seller in different areas, and then based on the report, the government can then make a decision, what kind of decision they have to make to dealing with this thing. Either they allow it, or they can set up a special area for these things here. Okay, so we use vision, AI, computer vision, and AI to deal with these things. That's not flux. Okay, let me see the other one. Okay, let me see. Let me see here. How about this one? Nope. Okay. How about this? Okay. This one. Oops. Wrong click. My mouse is. This one IoT doesn't use AI yet, but basically IoT only. Where is this guy? Imade Yoga Pratama. Nope. Nope. 22. 21. Nope. Let me see. How about 2020? Okay, this is the guy I'm looking for. This is the important one. This is the interesting one. So Imade Yoga Pratama is from Bali. He's building the apps for predicting fish prediction basically. So let me show you the apps. Go fish. Place. I think they remove it from Play Store now. Let me see if it is on Play Store. I think they remove it. It's called Go Fish. Oh no, Fish Go. Fish Go. Nope. Both of them can. Fish Go. Go Fish. Okay, it's done. It's gone. From so basically, this application is like this. Let me show you. Go Fish. This is interesting actually. Sorry, not Go Fish. Fish Go. Fish Go. Fishgo.id. So this is sorry, this is the Indonesian language. So basically, Let me see if there is any screenshot for the apps. So here they expand these things actually. Okay, the apps is anyway. So basically, the apps is the fisherman can tell where the fish got, the fish location at that time and this particular time, and then before they go to sea, they will see the apps and check where the fish is for tonight, and then they can go there. Basically, it use AI. The data they use is actually from NOAA, the weather NOAA satellite. NOAA satellite. You from NOAA weather satellite, you can get NOAA also give away for free the data for the sea temperature and sea current, and then people can check on this one. Okay, this is 7:30 now, so I have to finish. Okay, thank you very much for today.